Okay, welcome to Unit 8 of Introduction to AP Computer Science. This particular unit is about 2D or two-dimensional arrays. Now, we've already seen arrays in Unit 6. We've seen array lists in Unit 7, but let's just go back real quick and remind you what an array is. So I can make an array of integers, for example, and I can say scores, and use curly braces, and let's say here are my test scores: 56, I got 89, 100, I had a good day, and maybe a 94. So basically we have a set of numbers that are organized, and they all have some kind of theme. In this case, they are scores. So what we're going to be working on today is a two-dimensional array. Now, a two-dimensional array is an array that has multiple dimensions, but basically I think what helps to visualize it is if you think of a grid. So in this case, what you're seeing basically is a row. But what we're looking at, and this is not correct code, is what we're looking at is a row, multiple rows. Now this is not how you do it, but you say you had a row and some columns. So let me switch over here to a different program. I have this kind of set up for you. So basically, let's say we're looking at a 2D array. We've got a row, we've got another row, we've got another row, we've got 3 rows, we've got 3 columns. Okay, so what we're looking at is this is basically an array like we've already done. So this is index 0, that's the column. This is index 1, this is index 2, because there are 3 items. We start at 0. Now this would be row 1. Also notice it starts at 0. And then this also has a 0, a 1, and a 2. And then this final row has a 0, a 1, and a 2. So for most of what we're going to be doing, we're going to be looking at rows and then columns. So basically we have kind of an XY grid. But what we're doing is we would say this is row 0, column 0, row 0, column 1. So it's kind of YX. So it's a little bit confusing if you think of it that way. But if you think of it as rows and columns, it's pretty straightforward. Now I just put 1, 2, 3, 4, 5, 6, 7, 8, 9 in here just as an example, like a telephone keypad. But this could have been 34, this could have been 98. It doesn't have to be any particular value, especially if we're using, for example, in this case, integers. Let's see if I can undo that. Okay, so let's go back to JGrass, which we're using, and get started on a little bit of programming in 2D arrays. Now this is not as long a unit as some, at least the basic concepts, because we've already done arrays. We spent a lot of time on arrays already. So we're able to apply what we've learned to 2D arrays. So the first thing I want to do is I want to create a new array. So I'm going to make an array of integers, or 2D array. So normally we do it like that because we just have one row, but now we're going to have multiple rows. Okay? And I'm going to call my array just ARR. And I say new int. Okay? In this case, what I'm going to do is I'm going to do a 3 by 3 2D array. So 3 rows and three columns. Again, as a reminder, indices start at 0, so it'll be 0, 1, 2, and 0, 1, 2. That's it. That's all we got to do. It's pretty straightforward. If you print that, if you run that, nothing. We don't see anything, but that's basically how you create a 2D array. Now this would be a blank 2D array. Since it's an integer, each cell, I'm going to use the terminology cell, each cell would have a value of 0, because that's our default value for integers. Okay, so we'll move on to 8.2, which is basically traversing a 2D array. And there's also some stuff in there about algorithms. I'll do a little bit of that in this video, and the rest we'll kind of practice, I guess, as we go along. So using the example I had here, I'm going to go ahead and create this 1, 2, 3, 4, 5, 6, 7, 8, 9, and let's see if we can do that. So again, there are integers. We have our square brackets. I'm going to call this board because I'm thinking of this as something like either a tic-tac-toe board or something like that. And I'm going to go 1, 2, 3. comma 4 comma 5 comma 6, and then 7 comma 8 comma 9. Okay, so notice I've got one opening brace, one closing brace, and then I've got 3 separate rows. 1, 2, and 3. But again, remember, index-wise, this is 0. This is going to be 0 row. This is row 1, row 2. And then this is going to be column 0, column 0, column 0. Okay, so this is basically setting up what we saw earlier. So we got row 0, 1, 2, and 3. We've got row 1, 4, 5, and 6. Row 2, 7, 8, and 9. Okay. So traversing the array. Okay, so we're going to be using the same basic concepts we did before. So what I'm going to do is I'm going to say for int row. As I mentioned earlier, we start at 0. Row is going to be less than 3 because we've got 0, 1, and 2. There is no 3 because we start with 0 indexing as always. And then row plus plus. Okay, that should be a semicolon. Now, this is where it gets a little bit more interesting. We're going to need to have a nested loop, which we've seen before. And now we're going row by row. So for each row, so I want to do this row first. Now I got to go through each column in order. So I'm going to do for int call equals 0. Call, again, in this case, is less than 3. And then call plus plus. Okay, so now in here, what I'm just going to do is I'm just going to print out the cell. So watch what I do here. System.out.print. I'm going to use print here. You'll see why in a second. Board, and it's going to be row call. I'm going to put plus, I'm going to put a space after each one. Okay. So this is how you access a particular cell. Okay. So it's the row number. So let's go back to here, make it a little bit easier. So you start with the row number. So in this case, 0. And then you do the column. So 0, 0 is 1. 0, 1 is 2. 0, 2 is 3. Row increments. Now we go to row 1. 0, 1, 2. Then we go to row 2, 0, 1, 2. So we're just going in that order. And then after each row is printed, we'll print a blank line. Okay. So now what we should see on the screen is the same thing we saw over here. We should end up seeing 1, 2, 3, 4, 5, 6, 7, 8, 9. Unless we got an error, which that was a while ago, which somebody had told me. Let's run it again. Semicolons expected. Yeah, that's going to be one of those days, I can see. Okay, and there we go. We need to get the expected output. So we got 1, 2, 3, 4, 5, 6, 7, 8, 9. So we started out, row was 0, column was 0. So that's row 0, column 0. Then column increments. We're still on row 0. Column goes to 1. Increments. Column goes to 2. Increments. Now we're at 3. Then we print a blank line, move down, and we do the same thing over again. Okay, so that is one way to traverse a 2D array. Now, in this case, obviously, we're going through every single item in order. So we could do the same thing. I'm going to call this traversing an array with an enhanced for loop. Okay, so watch what I do here. Well, let's take a look at this first. What is this? Okay, thinking about looking at those symbols and that combination of numbers and commas, what exactly is that? If I took that out of there, what would it be? So hopefully you're thinking to yourself, well, it is an array of ints. And if you thought that, you would be correct. So what I'm going to do here, I'm going to do for int. Again, this is an array of ints. Each row is an array of ints, in an array called board. So in my mind, I'm thinking for each row, which in this case is an array of ints in the board, okay, so for each of these, I want to do something. So now I've got my row. Now what I can do, for int value in the row, system.out.print value plus quote space. Okay, and the same thing. After each row, I'm going to print out a blank line. And I should see the exact same thing. Okay, so let me run that. Make sure it's working. Okay, so we got the same thing. 1, 2, 3 to 9, and 1, 2, 3, 4, 5, 6, 7, 8, and 9. So it is working as expected. So let me just take a look at this one more time. So what we did there was for each row, okay, print out each value. Print a blank line. For next row, print out each value. Print a blank line. Each row, print out each value. End of the story. So you can see we can traverse a 2D array in the same way that we would traverse a 1D array or a single dimensional array. Okay, so pretty straightforward. We could also do a while loop. I'll leave that as an exercise to the viewer. So basically everything that we did with single dimensional arrays we can do with 2D arrays just by modifying the code a little bit. Okay, so we had a bunch of standard algorithms that we looked at in both the array unit and in the array list unit. So let's just take one of them and see how we might convert that so that it works in a 2D array. So let's think about finding the maximum value. Okay, so if you remember, what we did was we took the array, we started with the first value, and we said, okay, this is our maximum. Then we traversed the array, we checked every single value, and we said, okay, which one is the maximum? We're going to do the exact same thing here, okay, because it's the same principle. The algorithm doesn't change, but the way the data is accessed changes a little bit. Okay, so I'm going to go ahead and create an array, or a 2D array, I should say, of scores. Okay. And I'm going to say, let's see here. I'm just going to put some scores in there. And we got here, let's see, 45, 85, and let's say 75. And then let's say we got a 97, we had a good day there. 23 had a bad day there. And 76. Okay. So now notice in this case, it's not even. It's not 3 by 3 or anything like that. It's actually, we've got 2 rows, so it's a 2 by 3 2D array. Okay. Now, if you remember, when we did single dimensional arrays, we just assumed that the maximum value was the first number. It has to be one of the numbers, so we started there. You had to start it somewhere, so we started there. So what I'm going to do here in this case, I'm going to say int max value equals scores 0, 0. It's got to be some value. So I'm basically going to take a look at this. I'm going to say, hey, this is my max value for my purposes. And then I'm going to do the same thing I did before for int row equals 0. Not row equals 0. Row in this case is going to be less than 2 because we've got one row which is index 0 and a second row which is index 1. So we never get to 2. Row plus plus. Okay. Now we have the extra dimension we got to deal with for int call equals 0. Call is less than, in this case it's going to be 3 because we got 0, 1, 2. Call is less than 3. Call plus plus. And here's what we're going to do. If scores, and it's the same algorithm. Again, we're just accessing the data differently. Row call is greater than max value. Then we set the value of max value to the new value. Okay. And so this will iterate, or it will traverse, depending on how you want to say it, through all of these values, okay, and it will find the max value. Okay, so system.out.println, so max value equals plus max value. Okay, so let's run it, and we should get 97. Let's see what happens. Okay, there we go. We got max value equals 97. Okay, so that's basically all I wanted to do in this particular video. I didn't want to go through all of the standard algorithms. This would be a very good exercise for you to practice on your own, to go through and see if you can get them all working. Most of them will work similar to this, at least the ones where you're searching through the entire space of values. But now the ones where you're reversing, let's say you want to reverse the 1 and 3, the 4 and 6, 7 and 8, that might be a bit more of a challenge because you have to think about the row and that sort of thing. But or shifting might be a challenge if you're shifting around. But for the most part, most of them are very, very similar in that you just need to traverse and iterate through every single value, either to find the number of even numbers, for example, or to find the number that are greater than a certain value, whatever your condition might be. Okay, so just to review real quick, to create a 2D array, you need to declare the type. You need to put two sets of these, and then you need to just set the size. Remember, arrays cannot change in size once they have been initialized. And then we could also pre-populate by doing the same thing we did with single dimensional arrays, but just putting a bunch of them together. And then remember, iterating, we go row and column. Now, it is possible to go column row. You just switch them around. It's not a big deal. But in the case where you're printing, you got to go row column, or otherwise it's not going to print out correctly. For our purposes, the AP will be, as far as I know, all examples will be row and column. So we don't really need to worry too much about column row. So that might help simplify what you need to study. We can use enhanced for loops, but you just got to be really careful here, because what you're iterating through, the board isn't values. The board is a set of arrays, single dimensional arrays. So that's kind of an interesting structure. And then once we have the row, then we can get the values out. So we have two enhanced for loops there. And then, as I mentioned just a few minutes ago, the standard algorithms will all work with the 2D array, but you gotta do a little bit of thinking, especially in some of the ones where you're shifting. So you want to give that some thought. Anyway, so yeah, hopefully this is something we can practice and will help give you a good head start on that. Okay, good luck.